Hi everyone. This is a lesson preview and or review of lessons 4.1 through 4.4. Let's start with 4.1, extending multiplication facts. In lesson 4.1, we worked with developing a rule for extended multiplication facts. That is when we were multiplying with multiples of 10, 100, or 1,000. We start with our basic multiplication fact. 2 times 3 is 6. We can extend one of our factors by 10, so now we are doing 20 times 3, and we can extend it by 100, 200 times 3. So to solve 20 times 3, we have to think that we have 2 tens times 3, and that would give us 6 tens, or 60. And 200 times 3 means that we have 2 hundreds times 3, which will give us 6 hundreds, or 600. Then we extended our multiplication facts to multiplying tens by tens, starting with our basic fact, 3 times 5 is 15. Now it's extended into tens, 3 tens times 5 tens. So we still have our basic fact, 3 times 5 equals 15, and we're multiplying 10 by 10, which gives us 100, 1,500. In lesson 4.2, we continued to multiply with our extended facts. This time we were extending into much larger numbers. So we were using estimation first and reviewing 3 of our strategies for estimating. One strategy is called front-end estimation. Here you would keep your first digit the same and change all of your other digits to 0. This is not a very precise method for estimation, but it gives us a nice, easy number to work with. Close to estimation is a really helpful strategy. Choose a number that's close to your original number but easier to work with. So here I might choose 140,000. And of course I can always choose rounding to make my estimation. I could choose to round to the nearest 100,000 or to the nearest 10,000, depending on the situation. What I need to remember when estimating is some strategies are more precise than others, so it depends upon the situation in the story which strategy I choose. The reason why we make an estimate is so that we can compare our answer and see if our answer is reasonable. In lesson 4.3, we're learning to use a familiar model, the area model, to help us solve extended multiplication. So here we have Maya laying floor tile, and her room is 8 feet by 24 feet. So here we have our 8 by 24 rectangle. Now to find the area, we need to do 8 times 24. We will do this by decomposing or breaking apart the larger number and dividing our rectangle or partitioning our rectangle into smaller parts. So here I've taken my factor 8 and I've decomposed it. I broke it apart and made it smaller into 4 and 4 because 4 plus 4 is the same as 8. And here I have partitioned my rectangle. For 24, I decomposed 24 into 12 and 12, and I partitioned partitioned my rectangle. So now to find the area of this section, I would do 4 times 12. To find the area of this section, 4 times 12. This section, 4 times 12. And for this section, 4 times 12. So now I made my multiplication easier for myself. I found 4 times 12 for each section was 48. I added my 48 4 times, and I got 192 square feet, which means I'll need 192 tiles. Is this the only way we can partition and decompose for this problem? Of course not. You choose to decompose the numbers in a way that makes the problem easiest for you. Here I took 24 and I decomposed 24 into 10, 10, and 4. That makes the problem easy for me. 8 times 10, 8 times 10 here, and 8 times 4 here. So now I add my area of 80, 80, and 32, and I get the same answer, 192. How else can I decompose 24? How about 20 and 4? Eight times 20, 8 times 2 is 16. I'm doing 8 times 2 tens, so I have 16 tens, or 160 for this area. 8 times 4, 32. And when I add 160 and 32, I get the same answer. In lesson 4.4, we'll be converting liquid measures. This time, we'll be converting between liters and milliliters. You need to know that 1 liter is equal to 1,000 milliliters. And we can see that on this scale. So you should be able to tell me that 2 liters would be 2,000 milliliters. 3 liters would be 3,000 milliliters. So we could say a rule for going from liters to milliliters is times 1,000. Now, when we get into these smaller units and solving with decimals, we can use this scale to help us. So let's say we're solving this problem. If we sold 3.6 liters of lemonade to raise money for a field trip, how many milliliters would that be? So let's find 3.6 and go across. That would be 3,600 milliliters. What if the question was, we sold 3.5 liters? Okay, let's look. Uh-oh, 3.5's not there. What can I do? I see 3.4 and 3.6. I know 3.5 would be right in between those two. So 3.4 liters is equal to 3,400 milliliters, and 3.6 liters is equal to 3,600 milliliters. That means 3.5 liters would be right in between those two numbers. So it must be 3,500 milliliters. Okay, that was a review and preview of everything we've done in lessons 4.1 through 4.4. See you in class.